Hello everyone, welcome to my channel Middleware Technologies. Today we are going to look at how we can manage our Kubernetes cluster using Gitlab CICD workflow. Basically, as we know, Gitlab is used to manage the source code, and it is also used to manage the software development lifecycle of the application or the project that we are trying to build. But at the same time, GitLab can be used to manage your infrastructure as a code, and we can apply those code in order to provision our infrastructure. So that is what basically GitLab can be used for. But in order to use GitLab to manage your infrastructure, like let's say a Kubernetes cluster, we need to have some kind of an agent that can communicate with the GitLab server. So we will try to see how we can implement this model in this demo. So coming to my test environment, I have a GitLab server that is hosted on fedrest.stack.com, and I have a master node and a worker node which is hosting my Kubernetes cluster. Before jumping into the details of how we can implement this GitLab CICD workflow in order to manage our Kubernetes cluster, let us try to understand some of the terminologies. So the first thing is, what is GitLab agent server for Kubernetes? So basically, the GitLab server has an inbuilt feature that is Kubernetes agent server. So this agent is basically running in the GitLab server, which manages all the agents that are deployed or installed onto the Kubernetes cluster, and it communicates with the agents in order to manage the cluster. So that is the purpose of GitLab Kubernetes agent server. Next is the agent key. Basically, the cluster that we want to manage, that is the Kubernetes cluster, needs to have an agent installed on that, which is called a GitLab agent for Kubernetes, and also termed as agent key. So this cluster side component maintains a secure communication to the GitLab for Kubernetes management and deployment automation. So that is the whole purpose of the agent that we are deploying on the Kubernetes cluster side. And now let us try to understand what is push-based deployment. So in this demo, we are using GitLab CICD workflow in order to manage the Kubernetes cluster. So basically, we are pushing the manifest or the definition files related to the Kubernetes cluster from the GitLab CICD workflow, which when triggered, it will initiate the deployment or applying the manifest onto the Kubernetes cluster. So that is the push-based model. And we have a pull-based model also, wherein the Kubernetes cluster itself pulls the changes from the GitLab server as and when the events occur. So that is a different topic, but we are focusing on the push-based model for this demo. Now that we have understood the basics of the terms that are used for GitLab and Kubernetes integration, let us try to get into the implementation of this feature. So as a first step, we need to have a working Kubernetes cluster. So let me go into my shell, and this is my Kubernetes cluster master node. And if you go and do kubectl get nodes, so you can see there is a master node and there is a worker node which are in ready state. So you need to have a Kubernetes cluster that is in a working state for this demo. Now let us go into our next step, that is ensure a working GitLab server with GitLab runner. So basically, we want to use GitLab CICD pipeline or GitLab CICD workflow to manage our Kubernetes cluster. But in order to have GitLab CICD workflow or the pipeline to be executed, we need to have a GitLab server along with a GitLab runner on which we can execute our GitLab CICD workflow. So that is the second step, that we need to have our GitLab server along with the GitLab runner in a working state. So let me show you my GitLab server that is hosted on Fedress. So this is my GitLab server. So let me log in with my developer user. So this is my GitLab server which is hosted on Fedress, and it is having a self-signed certificate. So let me show you. This is the self-signed certificate which is installed on the GitLab server. And also we have runners which are used to execute our projects. Okay, so let me show you a runner. So let us go into settings, CI/CD for this project. So this is a demo project that I have been using, but this will show us the runner which we are executing on the CI/CD workflow on that server. So this is my runner which is in a running state, which can be used to execute the GitLab CI/CD workflow. And we can also check the GitLab server status and GitLab runner status from the command line. So this GitLab CTL status will show the GitLab server status, and the GitLab runner will show the GitLab runner status, which is in running state. So we have a working GitLab server, right? GitLab runner for this demo. Now let us go into our documentation, and let us go into our next step, that is step 3, set up the GitLab Kubernetes agent server. So basically, we need to have a Kubernetes agent server running on the GitLab server. And in my case, I have a self-managed GitLab server installed using the RPM based method, in which the GitLab agent, the Kubernetes agent server is by default enabled. So you can check the logs for var log GitLab CAS. So let me go to that folder, var log GitLab CAS. So GitLab CAS is holds this logs for Kubernetes agent server. And let me go to the current logs over here. So you can see running CAS version is this one. So these are the endpoints that are exposed for the Kubernetes agent server. So this tells us that the CAS server is up and running. At the same time, we need to have our self-sign certificate for the GitLab server installed at the following location. Okay, so let me go into that location also. So you can just copy the PEM file for your certificate, the self-sign certificate, into this location, and you can just reconfigure the GitLab server, and it will it will have a hash created and point it to the location of the certificate. Okay, and also there is one more thing we need to enable, that is the GitLab CAS environment variable, which will point to the certificate locations. Okay, so here, if you go to etc GitLab and open your gitlab.rb file, let's search for CAS, and you can see I have enabled this environment variable, which will basically tell the GitLab CAS server to look for certificates in the following location where we have deployed or installed our self-sign certificate. Okay, So once that is done, like you have your cache server up and running, and please note, like your cache server is by default exposed on the WebSocket protocol. So this is the WebSocket URL, you can say, wherein the Kubernetes agent server is listening. And you can see the fedrest.stack.com is the FQDN or the fully qualified domain name for my server. So in your case, like it will be different based on your host name. Okay, so this is basic setup for the Kubernetes agent server on the GitLab server. Now let us go into our next step, that is step 4, creating a agent configuration file for a repository. Okay, so in this case, so in this step, like what we are going to do is we are going to create a blank project in GitLab server. So let me go into the GitLab server and try to create a blank project named Kubernetes _ cache, and I will create in this in my namespace, that is dev, and this is going to be a private project, and let us not create any files in this, and create a project. So now our blank project is created, and we can just copy this commands in order to clone the project and push changes to our project. Before that, what we need to do is we need to unprotect our branch, because the default project protects our main branch from pushing the changes directly. Okay, so we'll go to settings, repository, and protected branches. So there is no protected branches currently, so we are good for now. So let me go to the project again, and let us try to clone it. So I'm going to clone it on my GitLab server itself for this demo. Let me see if I have another project. So I'll just move this. So that we can clone it freshly. So let me copy this commands and execute it over here. So it has cloned and it has pushed a change to the readme file. So if you go to the project, it will have that readme file available. Now let us go into our next step, that is creating an agent configuration file. So agent configuration file is basically a file that is used to manage your Kubernetes agent configuration. So that needs to be created in your repositories main branch, which will be executed as a part of GitLab CICD workflow. And we need to create the following structure first, that is we need to create a folder, GitLab agent and the agent name. Okay, so we will create this one, and here now we will create the config.yaml file, which will hold the Kubernetes agent configuration. And for now, like we can keep it empty. We'll just add that folder and commit those changes to the GitLab repository. So I'm just committing that .gitlab folder and the corresponding files, that the file config.yaml file that we have created, to the repository's main branch. So now you can see, like the GitLab, you're not allowed to push the code to protected branch because we have created a main branch, but right now it shows like we are not allowed to push to the main branch. So what we'll do is we'll go to repositories and do protected branch, unprotect. so anybody can push the changes. So this is only for demo purpose, but you need to protect your main branch from software lifecycle development perspective if you're doing it for a production deployment from the main branch. So now let us try to push our changes again, and you can see the changes are pushed, and you can see in the Kubernetes IAC project our GitLab's agent fedrest config.yaml file is created, which is currently empty, and that is fine. Now let us go into our documentation. Let us go into our next step, that is register the agent with GitLab server. So before we can install our agent on a Kubernetes cluster, first we need to register agent on the GitLab server so that we can generate a token or a security token, authentication token we can say, which can be used by the Kubernetes cluster to communicate with the GitLab server. So in order to do that, what we need to do is we need to go to the project, the Kubernetes project that we have created, and go to operate Kubernetes cluster. So here, like right now, we don't have any agent. So let us try to register, connect to a cluster, and here like add a agent configuration file to this repository, which we have already done, and so we can select that one. So we can select that one and do a registration for that agent. So this will generate a token, agent access token, which is basically used by the agent in order to communicate with the cluster. Okay, and this is the Helm installation command that. So this is the Helm commands that we need to install basically on the Kubernetes cluster master node in order to set up the agent on the Kubernetes cluster. So let me copy this onto my notes. So we'll keep it here, and we'll also copy the access token, which is the new one. So this is for reference purpose. So now that we have our agent registered, so we have generated a token, but this agent needs to be installed on the Kubernetes cluster so that we can get a connection to the agent from the CAS server. So for that, what we need to do is in the next step, that is step 6, install the GitLab agent for Kubernetes on the cluster. So let us, before we can install the Helm commands, we need to ensure that we have Helm installed on our master node, so wherein we will be running the Helm commands. So we will just ensure that the Helm is installed. So we have Helm installed on our master node. Now we can do add the repo for Helm. So that already exists. We can just update the repo. So that is also updated. Now the important step is installing the agent. Okay, so here like what we are going to do is we are going to take this same command and try to install that agent and see what happens. So let me try to install. So you can see we are installing agent named Fedrest with this following image, that is the GitLab agent image, and it will create this namespace if it is not present. So, and the image that version that we are using for GitLab agent is this one, and the token that that has been generated from the registration step is used over here so that it can communicate with the CAS server and the CAS server endpoint, which is the WebSocket endpoint on which the CAS server is listening, so that the communication can be established. So let us try to execute it as it is. Let me do kubectl get pods -a, and you can see like the GitLab agent is installed on the in the following namespace. But let us try to check the logs for one of the pod in that namespace. And you can see like the registration has been failed for the following agent because the endpoint that is trying to communicate with the CAS server, the TLS certificate is not it is not able to verify the certificate authority. Basically, the certificate has been signed by self, so it is not able to authorize that certificate. So that is why the agent is not able to register. So now we have seen like the agent is unable to communicate with the CAS server WebSocket, and it is failing with the TLS fail to verify certificate. Let us try to uninstall the agent from the cluster. This is going to uninstall the agent, and you can check kubectl get pods -a, and you will not have any agents running. Now what we can do is we can just try to run the same command which is helm upgrade. So let me see the token MUG. So that is the token. So let us try to run the same command. Additionally, like we will apply this slash, and we will set the config that is CAS CA certificate. So basically, like we will provide the CA certificate for our GitLab server so that the agent will be able to trust the CA certificate. Agent will be able to trust the GitLab server certificate using the CA certificate that we have provided. Okay, so now let me copy this. Let me clear my screen and try to apply that command. So now our agent is deployed. So let us check the kubectl get pods -a, and you will see the agent is deployed in the following namespace. So let me check the logs also for one of the pod. And you can see that error is gone and the agent is registered. And if you go into the project Kubernetes IAC and check the Kubernetes cluster status, like you will see it is connected. Now let us go into our next step, that is step 8, updating the GitLab CICD workflow. So here in this step, what we are going to do is we are going to create a GitLab CI.yaml file, which is going to be our pipeline. So let me go to my project and create that YAML file, CICD YAML file. And here, like we will be copying this whole CI/CD workflow, which we are going to execute. Using the GitLab CI/CD. Let me save this. So So you can see like here, like we have only one stage, that is stage deploy, and this is going to be executed as the job deploy, and we are going to execute the following script steps. Basically what we are doing is we are setting the Kubernetes kubectl config CA certificate to point to the self-sign certificate content. So this is basically the base 64 output of the self-sign certificate. So if you go to this command, like where I have converted my certificate, this is the certificate to base 64 format. So this is the basic command that you can use in order to convert your PEM file certificate into base 64 format. And I have taken this content and just copied into the CICD YAML file. So you can see like this is the same as what I have just generated. Okay, so once we have configured the clusters, so the default cluster that we get from the agent is GitLab, and we have applied the certificate authority CA certificate pointing to the self-sign certificate. Now we can just do a config view to get our config output and get the context that have been like generated with this agent installation, and we'll use the following context, which is the dev namespace and the project colon the Kubernetes agent name. So this is going to be our context that we can use in order to communicate with the cluster, and the command that we are going to execute is kubectl get pods. Okay, so in case like you do not have a kubectl client which is configured with the CA certificate, you can just execute the kubectl command in insecure manner by applying this option. Okay, so let me now push these changes. So we need to add, commit these changes, create GitLab CICD workflow, and now we can push these changes to main. So now like we have pushed our changes. So there is one more thing that I need to mention over here. Like I have my GitLab runner with the shell executor available. So I'm not using a Docker executor or Kubernetes executor, but I have a shell executor. So what I did is I installed the kubectl tool on the GitLab runner itself, which is also running on the same server wherein the GitLab server is available. So we can just run the following curl command in order to install kubectl on the GitLab runner server. So this is the curl command that you can get from the Kubernetes documentation, and install the kubectl client. So once that is done, we are ready to execute our CI/CD workflow, which will do configuration, update the context to use the appropriate one, and try to list the pods in the default namespace. Let me go to the project and go to build pipelines, and let us try to execute this pipeline manually. So let me execute this pipeline. And this is going to trigger our deploy step. Let me open this one, and you can see like we have executed the following steps. Like that is, we have set the config for the cluster certificate authority data. Then we have done the config view, wherein it will show that this is our cluster GitLab that we get with the agent, and the user is agent 6, that is the agent ID that got registered on the GitLab server, and the name of the context is the username, your namespace, and the repository name, and colon the agent name. And currently, like, the current context is not set, so we are getting the context. So this is the context, and we are going to set the context, that is use the following context. Okay, and then like we are able to execute the kubectl get pods. It will show like what all pods are running on my cluster. So if you go to my cluster and do kubectl get pods, like you will see like these are the pods, Nginx pods, and the job that has been completed that are available. So the same thing that you can see over here. So this is how like you can manage your Kubernetes cluster by executing or applying your manifests using the GitLab CICD workflow. And this is a push-based model wherein we are manually triggering the GitLab CI/CD workflow, or based on the changes that we are pushing to the branch, and we are triggering the GitLab CI/CD to connect to the Kubernetes cluster and apply those manifests. So the thing is, like when we install the agent, we get a context that we can utilize in our GitLab CI/CD workflow. So the last step, that is validating the GitLab CI/CD pipeline. So here like we have already seen, like we have validated our pipeline. So it has executed the deploy steps successfully. The initial, we have been able to successfully execute the pipeline and get the output from the Kubernetes cluster. Okay, so I hope you enjoyed watching this video. Thank you all. Thanks for watching this video, and you guys have a great day.